Okay, welcome back. This was an optional video. If you're having trouble balancing these chemical equations, I get it. This just takes a little practice, but we're going to go over this page. We're going to start off by counting the atoms on each side, and I gave you this little area down here to work on things. So we look in here, we have one carbon, and then there's 3, 4, 5 hydrogens. And then there's 2 carbons, okay? And then there's 1, 2, 3 oxygens, and then there's 1 sodium. Okay. On the product side, there's 1, 2 carbons, and then there's 3, 4, 5 hydrogens. And then there's 1, 2, 3 oxygens, and then there's 1 sodium. So we check 2, 2, 5, 5, 3, 3, 1, 1. This looks like it's balanced. So we're going to put the 1 coefficients in each of the boxes, and then we'll work on this one. Okay, so we see that there's 1 iron, and then in the formula HCl there's 1 hydrogen, and 1 chlorine. And then in this formula, FeCl2, there's 1 iron and 2 chlorines. And then in the H2, there's 2 hydrogens. So I look to see what's out of balance. The irons look like they're in balance. There's not enough hydrogen and chlorine over here on the reactant side. There's twice as much coming out on the product side. So I'm going to put a 2 here. When I do that, that changes this to a 2 and this to a 2 because there's 2 of the whole formula, and now it looks balanced, so I'll put the 1s in the other coefficients. Problem number 3, we have this CH4 plus this diatomic oxygen, and it's yielding this carbon dioxide and a water molecule. So we count, we have 1 carbon in this formula, and we have 4 hydrogens, and we have 2 oxygens. Over here on the product side, in the CO2, we have 1 carbon and 2 oxygens. And then I see 2 hydrogens and 1 more oxygen. So we're going to bump that up to a 3. Now, this again is where you kind of got to use a little bit of your math sense. Okay. Oxygen over here comes in groups of 2 with the O2. Over here, I have an odd number of oxygens. Okay. I have 2 in the carbon dioxide and 1 in the water, and I need to have it be an even number. So I'm going to double up on this water, and when I do that, that makes 4 hydrogens, and then I have the 2 carbons plus the 2 now in the water is a total of 4. Okay. I see that I don't have enough oxygen over here, so I'm going to put a 2 coefficient there. When I do that, that makes this a 4. Okay, and I have 1, 1, 4, 4, 4, 4. So this looks like it's balanced now. Okay. Now in this formula Fe2O3, there's 2 irons, 3 oxygens, and this is elemental carbon, so there's 1 carbon. Over here it shows elemental iron, and then carbon monoxide, so there's 1 carbon and 1 oxygen. Okay. I look to see what's the most out of balance. And what's the most out of balance is the oxygen, okay? So I'm going to put a 3 coefficient over here, make 3 carbon monoxides, and that makes this a 3, and that makes this a 3. And then I see I don't have enough iron over here, so I'm going to make this a 2, and this a 2. And then I see I don't have enough carbon over here, so I'm going to make this a 3. When I do that, that makes this a 3. And then I'm going to put a 1 here. That looks like it's in balance now. Okay, in this manganese oxide, I have 1 manganese, 2 oxygens, and then in the HCl, there's 1 hydrogen and 1 chlorine. Over here, in this manganese chloride, I have 1, and I have 2 chlorines. Over here, 2 more chlorines, so that's 4. And then in the H2O, I have 2 waters and 1 oxygen. So I'm going to start off with what's most out of balance. And what looks most out of balance is I don't have enough chlorine over here. So I'm going to put 4 in front of this. That's going to give me 4 hydrogens and 4 chlorines. A lot of times when you fix one thing, you break something else. Now I see I don't have enough hydrogen and oxygen on the product side, and hydrogen and oxygen is coming here from this water. So I'm going to make this a 2 coefficient, and that's 2 times 2, that makes this 4 hydrogens, and 2 times 1 is 2 oxygens. And I check for balance, 1, 1, 2, 2, 4, 4. So this looks balanced. So we're going to put a 1 in the rest of these boxes. This is electronic, it needs something. Okay, then I have the lithium plus the water is going to yield this lithium hydroxide and this diatomic hydrogen. So I see 1 lithium, 2 waters, 1 oxygen. Over here, I have 1 lithium, 1 oxygen, and 3 hydrogens. Now again, I got to kind of use some sense. I've got an odd number of hydrogens over here, and hydrogens only come in an even number over here. So I need to make this an even number also. So I'm going to try putting a 2 in front of the lithium hydroxide because that's where the single one was. When I do that, it's taking 2 lithiums, 2 oxygens, and now I have 4 hydrogens. I have 2 times 1 is 2, plus these 2 is 4. Now I look over here, I don't have enough hydrogen and oxygen, but if I put a 2 in front of the water, that makes this a 4, and it makes this a 2, and then I need a 2 in front of the lithium, and that makes this a 2. Now it looks like it's balanced. I'm going to put a 1 there, and move on to the next one. Okay, in CH4, there's 1 carbon, 4 hydrogens, and in the Br2, there's 2 bromines. In the C, there's 1 Br4, and then H, 1, and then 1 more bromine. Okay, so again, the bromine over here is in an even number. Over here I have an odd number, and the odd number is coming from this 1. So I'm going to try putting a 2 in front of this. Also, I see that I have 4 hydrogens over here, and I haven't got but 1 here, so I really need to bump this all the way up to 4. When I do that, I have 4 bromines here, and now I have 4 bromines here, so that's going to make this an 8. And then I have 4 hydrogens now. Okay, so I don't have enough bromine over here. I have 8 on the product side, only 2 on the reactant side. So if I put a 4 here, 4 times 2 is 8. And check 1, 1, 4, 4, 8, 8. I'm going to put 1 here, 1 here. Okay, and on this one, I have 1 copper, 1 oxygen, 1 nitrogen, and 3 hydrogens. Over here, I have 1 carbon, 1 oxygen, and there's 2 hydrogens in the water, and then 2 nitrogens. Okay, this is one of those times where I see nitrogen is in a group of 2. Nitrogen is in a, hydrogen is in a group of 2 here, and hydrogen is in a group of 3 here. So this is like one of those math problems where buns come in packages of 3 and hot dogs come in packages of 2, and if you're throwing a party and you want to have an equal number of buns and hot dogs, you have to find a common multiple. So the common multiple between 3 and 2 is 6. So I'm going to put a 2 here. And when I do that, that makes this 2 nitrogens and 6 hydrogens. And when I put the 3 here, okay, and I make 3 waters, that's going to give me 3 times 2 is 6 hydrogens, and 3 times 1 is 3 oxygens. Okay? So I see that I don't have enough oxygen on the reactant side. I see it comes over here, so I'm going to put a 3 here, and then it makes this 3 coppers and 3 oxygens. So I'm going to need a 3 here, That makes this 3 coppers. 3, 3, 2, 2, 2. So this looks balanced. Put 1 there. Okay. Now in this, this is respiration. Got the glucose plus the oxygen. We exhale carbon dioxide and water. So we have 6 carbons, 12 hydrogens. We have 6 plus 2. Okay, so 8 oxygens. Over here, we have 1 carbon. We have 2 oxygens. We have 1 hydrogen and 1 more oxygen. Okay. So the hydrogens are way out of balance. Okay, there's 12 here. There's 1 here. They come in groups of 2 here. So I need to put a 6 here. When I do that, 6 times 2 is there's going to be 12 hydrogens, and then there's 6 oxygens here, waters. Okay. Now the next thing that I see that's way out of balance are these carbons. There's 6 here and only 1 here. So I know I got to put a 6 coefficient here. That's going to make this a 6, and 6 times 2 is 12 oxygens. So now I have a total of 18 oxygens on this side. Okay. And I only have 6 plus 2 is 8 on this side. And over here, I have 6 plus 12 is 18. So I'm going to try a 6 here. When I do that, 6 times 2 is 12 oxygens from the O2. So now I have 6 plus 12 is 18. 12 plus 6 is 18. 6, 6, 12, 12. So this looks like it's balanced. Okay? And it looks like we're finished.